Good morning, everybody. My name is Angel, and thank you for watching my presentation. I hope you find it interesting and informative. The topic of my presentation is telerobotics. In a sense, how can you remove or distance your brain from your body? Well, the term tele, as you know, is derived from the Greek, and it means distant. It's generalized to imply a barrier between the user and the environment. Why we have to use or why we need telerobotic systems? Well, that's because how many of you know people who is suffering a disease and the best doctors are on the other side of the world without being able to do anything? Or maybe a explosion of a bomb causing damage, and we can disable it at a distance. These are a few reasons why telerobotics are becoming a key part of the development of humanity. First of all, I want you to know that telerobotics are often conceptually split in two sides. The first one is the local side with the human operator, and it has also the element necessary to support the system's connections, as could be joysticks, monitors, keyboards, and other input-output devices. The other one is the remote side. The remote side contains the robot and other supporting elements as could be to control or sensors of the robot. Once you know that, I want to divide my presentation in three main areas. To start with, I'm looking at a historical perspective. Then I will move on different applications. And finally, I will talk about control architectures. So, history, applications, and control architectures. If we talk about history, we have to talk about Raymond Goerth. Raymond Goerth used mechanical and electrical teleoperators in earlier 1950s to handle radioactive materials. That was to protect himself from these materials. In the beginning of 1960s, the effects of time delay on teleoperators become a topic of research. Now the telerobotic system CRL model M2 of 1982 was the first one to realize force feedback while separating master and slave electronics. In 1993, the first telerobotic system was flown to the space by German Space Lab mission D2 on board the space shuttle Columbia. And the first transatlantic telesurgery was in 2001, and it demonstrates that telerobotics are useful even at delicate field of surgery. The feasibility of telerobotics. I was talking about history of telerobotics, and now I will talk about different applications. You have to know that all the applications have been motivated by issues of the human safety in hazardous environments. Or maybe because everywhere we have or we use a robot, we can find a telerobotic system. To improve operations, for example, we have minimally invasive surgery. The telerobotics allowed procedures to be performed through small incisions, and that thing reduce the trauma of the patient, and is very difficult to the traditional operations or the traditional surgery. Well, to protect from hazardous environments, we have maybe the telerobotics in chemical or nuclear plants, or to manipulate electric lines, or maybe to disarming explosives. And well, in the space, robotics is a classic application for telerobotics. You can see that in NASA of the rovers, maybe, or maybe the orbital robotics in the German technology experiment Robics, with robot component verification on ESS, and is the most advanced telerobotic system in the world now. Well, we have talked about the applications, and you have to see that it is related to improve operations, or maybe to protect us from different hazardous environments. Well, the last point I have to talk, the last main point, is about control architectures. This will able you to use one of these architectures in your future projects. Well, first of all, I want to say the three main aspects that are, first of all, supervisory control, second one, shared control, and third one, direct control. Supervisory control, in this one, is the user and the slave are not connected strongly, are connected loosely, and it has a strong local autonomy. It was introduced by Ferrell and Sendian in 1967, and well, this tried to reduce the time delay visual feedback with predictive stereographics. Well, and this gives more and more autonomy and intelligence to the system. Well, the second one is based on local sensory feedback loops at the teleoperator site, and well, this gives a bit of autonomy with normal or a kind of sensory intelligence. Well, and the last one is the direct control, that these don't have any autonomy or intelligence. The master controls the slave via master interface, no more. Okay, I think I cover every application, every architecture of the telerobotics. The main points are covered. As I talked before, we have talked about history first of all. Next, I talk about applications, and finally about architectures. Well, to conclude, I think that telerobotics are in progress and will be very important for us in the future, because it improves some operations, and it also protects us from hazardous environments, and it's good for us. Well, I want to do an answer and question session, but by this I will be complex. You can write me. And well, thank you for listening to me, and Happy New Year. Bye.